Hi everyone, and welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials, Maximum Deflections in Beams and Shaft. We had reviewed this problem in last two videos with two different approaches, like the drawing method, drawing the shear moment and deflection diagrams, as well as the moment area method. We want to solve it with a third solution, like which is the Castigliano's method to calculate delta maximum deflection at B. So first, if you look at the force and deflection diagram, you can easily see the area under this triangle, which is a half of P times delta B, is equal to U. So this is the energy stored. This is like a general, you can call it like delta B or any general delta or delta. Just don't be confused on that. So the area on this triangle is the energy stored in the system. That's from physics, and while in Castigliano's method, we'll talk about the details of this Italian engineer who developed the Castigliano's theorem and how he used it based off the partial derivative of energy function, a strain energy function, which leads to calculation of a delta or deflection. But now we just focus on the application of that Castigliano's formula. He just uh, confirmed that this strain energy stored in a system is the integration from 0 to L, the entire length of the beam or shaft, m squared over 2ei dx. If that beam is subjected to a moment, so or create or kind of loading that create moments. So if you just having this concentrated load moving by a distance of x from the free end, you can easily feel the moment of m sub x there. So this is the same moment we use in the Castigliano's method to calculate the strain energy function in order to finally calculate the connect the two dots. So this is the first part, which comes from physics, and the other part is U, which is coming from our third solution, which is Castigliano's theorem or method. And let's replace mx, which is like if you cut the beam by the distance of x, mx is definitely p times x. Moment is nothing but the force times the arm. And if you replace that in the Castigliano's formula, that's like p squared times x squared. This is just m2. This is like m squared over 2ei. This is m squared over 2ei dx. This is the same formula which is the Castigliano's theorem. From 0 to L, that's the limit of our integration. And if you do the math, the constant, all of this part is constant, and we just have the integration of x squared dx, which gives us p squared L cubed over 6ei. That's u from the Castigliano's method. And from first part, we know that U is the strain energy, is the area under the P delta. So if you make these two equations equal to each other, then cancel out the part you can cancel with each other. It just gives you delta B, or the maximum deflection at the free end of this beam due to a concentrated loading at the free end, which we call it like delta B, is equal to PL cubed over 3EI. This is the same parametric value which we calculate in last two videos with two other approaches. So we have solved this problem with solution one, which was the drawing method. Solution two was the moment area method. And the last one is solution 3, which is the Castigliano's theorem. So you can easily see you can solve each of these beams problem with as many different approach which you want, and you get to the same results. Thank you. We'll solve more problems in beams and shaft. See you in next videos.